Okay, so in order for us to find the square root of 121, what is the square root of 121? All right, so don't forget you have to say plus or minus 11. Why? Because negative 11 times negative 11 is 121. 11 times 11 is 121. So if I give you something like this, if I say, let's find the square root of 225, and I think that was in your homework, what's the answer, everybody? Plus or minus 15. Okay? So some of you did this. Now, what happens when I tell you find the square root of it, a cube root, of a number? What do I need?
You find it and then you cube it.
So instead of what number times itself gives you the 121, what number times itself 3 times gives you 64? So what is it? 4 times 4 times 4. Okay, so from these two, you're going to need 11 times 11 or 15 times 15, right? When it's a cube root, you're going to need 4 times 4 times 4. Can you see the difference?
Can you divide it 3 times?
Yeah.
And then I'll tell you.
Yes, not divided by 3. You have to find the same number times itself. Now, who can tell me this one? Fourth root of 16. 4 times 4 is square root. Okay? So this is 2, because 2 times 2 times 2 times 2 is 16. Okay? Now, somebody said, do you remember the factor tree? You said 4 times 4, right? But then you have to break it again as 2 times 2, 2 times 2. Can you see that? So it's basically working with a factor tree. Okay? And that is, the homework that I gave you yesterday was only numerical. Right? Now, what if I give you this? X squared equals 9. X squared was equal to 9. How do I solve that? I have to take square root, and then my answer is going to be what?
3.
Excuse me? Plus or minus 3. Don't forget, I'm not going to give you extra points if you don't say it correctly. All right, so let's do this one correctly. X squared equals 49. What's the answer? There we go. Excellent. It's very simple when it's just numbers, right? Okay, I'm going to ask you to find square root of 128, a to the 4th, b to the 3rd, c to the 6th. All right? So on this one, you can see the calculator is not going to help you because there's letters involved, right? Okay, so first of all, let's do a number tree for 128. What makes 128? 64 times 2. All right, let's go ahead and do this. What makes 64? 32 times 2 times that 2, right? 8 times 4, 2 times 2, right? All right, so 8, do we know, is 2 times 2 times 2, 3 of them, right? 8, 4, and the 2 and 2. Can you see that? So if I need to do square root, that means I need 2 of these, 2 of these, and 2 of these. Can you see that? Everybody, do we understand that part? So my answer is going to be 2 times 2 times 2, and there's a little 2 in there that I couldn't get up. Can you see? Right? I have one set, one set, one set, and one that didn't come out. Are we okay so far? Now, my A's. I have 4 A's. A, A. Correct? That didn't look like an A. All right, so now I need sets of 2, correct? So I have 2 sets. So I have A and A outside, correct? How about the B's? I have B, B, and B. Again, I need a set of 2 because it's square root. So I have a B and a lonely B that I couldn't use, correct? And then the C's. How many C's do I have? And how many sets do I need? And we have 3 sets of C. So I have 1, 2, 3. So the answer is going to be 8 a squared b c to the third, and do not forget what stayed inside the radical. If the problem, instead of being square root, is going to be cube root of 16 x to the fourth y to the fifth. Okay, this is the case in which separating everything might be a little bit easier. So what makes 16? No, 4 times 4, it's not necessary because we need a cube root, so I need 3 of each. 2 times 2 times 2 times 2. X, 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 and you say it's a long, but I want you to see the process. Everybody is not paying attention. All right, because it's to the cube root, you need a group of 3. You need a group of 3. You need a group of 3. Can you see the difference? It's not square root, it's cube root. So the groups are different. So you're going to have 1, 2 out, 1, 2 in, 1x out, 1x in, 1y out, and y squared in. That is the solution. Okay? So